Hello everyone, myself Dr. Feruza Demirachkar, and today we will see a 8051 program to arrange the given numbers in ascending or descending order by using bubble sort. First we will see what do you mean by bubble sort. Here bubble sort is a sorting algorithm which operates by repeatedly stepping through the series of elements or a list of elements, and it will compare the adjacent elements. If they are in the wrong order, then it will swap the elements and it will move to the next pair. If they are in the correct order, then it will move to the next pair. Then it will check for the subsequent pairs, and if the pairs are still at you have some other pairs to compare, then it will go to the next pair, and again this loop continues, and at the last you will get the sorted list. If the list is ended, then you will get the sorted list. So here the first step is the initial comparison, where we start from the beginning of the list and compare the first two elements. Then we have swapping of the elements, that is, if the first element is larger than the second one, then you have to swap them. After that, you have to move to the next pair of the elements and repeat the comparison and swapping. Then after each complete pass through the list, the largest unsorted element will bubble up to its correct position at the end of the list, and this process continues for the rest of the unsorted elements until no swaps are needed, indicating that the list is sorted. We will see an example now. Suppose I have these numbers which I am storing at 30H, 31H, 32H and 33H location. So these are the numbers before execution. Now I want to arrange this in the ascending order. So I have to get at the same memory locations. I should get these numbers, that is 1, 2, 3 and 4. Okay. Before execution, I have 4, 3, 2, 1. These are not arranged in the ascending order. These are stored at the memory locations starting from 30H. Whereas after execution, I have to get 1, 2, 3, 4, which are arranged or sorted in the ascending order, but we will get the output in this location only, that is starting from the memory location 30H. Now how we do that, we'll see first. At 30H, 31H, 32H and 33H, we have 4, 3, 2 and 1 respectively. What we'll do here in bubble sort is, first we'll compare the first two elements. Now if the second element is smaller one, or the first element is larger one, then we will swap it. Okay, that is the first element, it is larger than the second one, so what we'll do, we will swap it. After swapping it, we get 3 at this position, that is at 30H, and 4 at 31H, and remaining two numbers will be as it is. Next what we'll do is, we will compare 4 and 2. This 3 will be kept as it is. We'll compare 4 and 2. Now 4 is greater than 2, so we have to swap it. We have to swap it. What we'll get? We'll get 2 and 4. We have swapped them. Now remaining is 1. In the next step, what we do is, we will keep 3 and 2 as it is, and we will compare 4 with 1. Now 4 is larger than 1, so we will swap them and we will get 1 and 4. So what we have done in this pass, we have moved the largest number at the end. Okay. So here, this is the first pass, and how many steps we are doing here? We are having 3 steps. Okay. Then this will be our second pass. Now the number of passes and the number of steps, it will be 1 less than the array size. Here we have taken 4 numbers. We are we want to arrange 4 numbers here in the descending or the ascending order. So the array size here, it is 4. Where here the number of passes and the number of steps, that will be 1 less than the array size. So here we are getting 3 steps and we'll get 3 passes. Okay. Next we'll have a second pass. this will be the array of the second pass. So the second pass is 3, 2, 1, 4 at the memory locations 30H, 31H, 32H and 33H respectively. Now we want to sort these. So here we'll start by comparing 3 with 2. So here 3 is greater than 2. There will be a swap. So 2 has come here and 3 has come in the 31st location. Remaining two numbers will be same. Now we will not go for comparing this number. That is at the end. Already we have got this highest number at the last position. We will not compare that. Next, 2 will be kept as it is. We'll compare 3 and 1. So 3 is larger than 1. We'll swap it and we get 1 and 3. And 4 will be kept as it is. So in this round, what we got? We got 3 and 4 at the end. Okay. Now left are 2 and 1. So this was the second pass. How many steps are there? There are 2 steps here. Fine. Next, this will be our third pass. That is this one. This is our third pass. So, sorry, for the third pass, we have this array. What we have to do now? We have to compare 2 and 1. In between 2 and 1, 2 is larger. So we have to swap it. We'll get 1 and 2 and 3 and 4 will be as it is. So our array is sorted here in the ascending order. So this was our third pass. In the third pass, we have only one step and this is our final arranged array in the ascending order. Okay. Now we'll see the program. Before that, we'll see what is CJNE, that is compare jump if not equal. Here we are using this instruction. So we will see what is this instruction. CJNE is compare jump if not equal. So here you will be having destination, source and address. Now here carry flag will be set if the destination is smaller than the source. Otherwise it is cleared. So here what happens is you have to compare the values. That is, you are comparing the destination and the source address. Destination and the source value. And here if they are equal, okay, then you have to continue with the execution of the next step. If not, then you have to jump to the specified address in this instruction and you have to implement the conditional logic. So here you may have any one form of these of this instruction, that is CJNE a comma direct comma relative address. That is, destination may be A, source may be direct byte. So here it will compare the direct byte with the accumulator and jumps if not equal to the relative address. Then next, here CJNE a comma hash data comma relative address. So here it compares the immediate data to the value in the accumulator and it jumps if not equal to the address, that is the relative address. Next is CJNE rn comma hash data comma relative address. So it will compare the immediate data to the value in the register and it jumps if not equal to. Next is CJNE at RI comma hash data comma relative address. It will compare the immediate data to the indirect register and jumps if not equal to. These are the execution steps of the program. The program initializes the registers. Here we'll be using register R3 and R2. Next, it enters a nested loop to process the values from the memory locations, which will be starting at 30H. Then for each pair of values, it compares the value in the accumulator with the value in the register B. For the register B, we have used the address 0F0H. So that is the address of the B register and it performs swap if necessary. Finally, the program enters, once the inner loop completes, that is here, once the inner loop is completed, it returns to the outer loop until all the iterations are finished. And finally, the program enters an infinite loop to keep running. These are the general execution steps. So what we'll do here, we'll initialize the registers, then we'll enter some nested loops, and there we'll compare some values. If the values are not equal and if the swap is necessary, we'll perform a swap. Then we'll continue with the inner loop. Okay, here we'll continue with the inner loop. Or if the swap is not necessary, then here it will not perform the swap, it will directly continue to the loop. Once the inner loop is completed, then it will come to the outer loop. It will complete all the iterations of the outer loop, and then it will enter the infinite loop to halt the program. This is a program for ascending order, that is arranging the numbers in the ascending order. So here we are arranging only 4 numbers. The org0000H, it is the starting address for the program. It tells the assembler where to place the code in the memory. Now next is move R3 comma #04H. This instruction moves the immediate value 04 into the register R3, and that is nothing but our array size. Next is decrement R3. It decrements the value of register R3 by 1. So now R3 will be 3. Next we have up1, move R2 comma #04H. Up1 is the label which is used for looping, and the program will jump here at certain points. Move R2 comma #04H. It moves the value 04 into the register R2. Okay, then decrement R2, that is it will decrement the value of R2 by 1. So now R2 becomes equal to 3. Next is move R0 comma #30H. So here it moves the immediate value 30H into the register R0. Then we have up colon move A comma at R0. So this will load the value pointed by the register R0, that is the memory location 30H, into the accumulator A. Then we have increment R0. It will increment R0 by 1. So now R0 points to the next memory location, that is R0 is equal to 31H. Then we have move B comma at R0, that is it moves a value at memory location, that is the 31H, into the B register. Then we have CJNE A comma 0F0H comma again. So here this compares the value in the accumulator with the value at this address, and if they are not equal, the program jumps to the location again, sorry, not location, to the label again, and if they are equal, it will continue the execution from the next instruction. Then we have again JC down. So this is the label where the program jumps if the values in A and the value in the address 0F0H are not equal. Then we have JC down if the previous comparison, that is CJNE, it results in a carry. Okay, that is A was less than that of the value in 0F0H, then it will jump to the label down. Okay, so here it will jump to the level down. JC down is what? That is if the previous comparison, that is here we are comparing. Okay, we are comparing the values of A and the value in the address 0F0. If these will result in a carry, okay, that is A was less than that of the value in 0F0, then it has to jump to what? It has to jump to the level down. Then we have XCH A comma at R0. It will exchange the contents of the accumulator A with the value at the memory location pointed by R0. Then we have decrement R0. It will decrement R0 by 1. So the program goes back to the previous memory location. Then we have move at R0 comma A. Here it will move the value in the accumulator A to the memory location pointed by R0. Then increment R0, it will increment R0 back to the next memory location. Then we have down label, that is this label this is the label for the program flow to go if the carry was set in this instruction, that is JC instruction, and the program will jump here after the JC instruction. Then we have here DJNZ R2 comma up. This will decrement R2 by 1 and jumps to the up label. Here it will jumps to the up level if R2 is not 0, and this will create a loop that will repeat the inner part of the program, okay, until R2 reaches 0. Then we have here DJNZ R3 comma up 1. Here it will decrement R3 by 1 and it will jump to the label here up 1, okay, if R3 is not 0, and this creates the another loop that will repeat the process until R3 reaches 0. Then we have H colon S jump H. This is nothing but a like infinite loop that keeps the program running at the level H, and this ensures that after all loops finish the program will not exit and will just keep looping here infinitely, and then we will end the program by using the end directive. This was the brief explanation of the program. Now here we'll see in detail the explanation of this program. Here the first three instructions, that is org 0000000h, then move R3 comma hash 04h and decrement R3 is there. So here what we'll do, this directive, it will sets the starting address for the program, okay. Then we have initialized the register R3 to 04. After that we have decrement R3, that is register R3 is decremented to prepare for the looping. Now we have the first loop. What is the first one? Up 1 colon move R2 comma hash 04h. Then we have decrement R2. So here this label, that is up 1, it will mark the start of the outer loop, okay. Then we have move R2 comma hash 04h. Here it will initialize R2, excuse me, sorry. So here it will initialize R2 and that means it will set the register R2 to 4 for the inner loop. Then decrement R2. So this will decreases R2 to 3 and this will be used for the inner loop, okay. Next we have the memory operations. These are the memory operations. Move R0 comma hash 30h. Then we have up colon move A comma at R0, increment R0, and move B comma at R0. So here move R0 comma hash 30h, it will set the R0 to point to the memory location 30h. Then next is, this is the label, up is the label marking the beginning of the inner loop. Then we will load the value, okay, from the memory location 30h into the accumulator A. Then we will increment R0 to the next memory location and we will load the value from the memory location 31h into the register B. Next is comparison and the swapping. So here we are using CJNE A comma 0F0H comma again. This will compare the value in A with the value at an address 0F0H, and if they are not equal, it jumps to the label again, okay. Here if they are not equal, it jumps to the label again. Suppose here Now if a is less than the value at 0f0h, is it less, then it will jump to the label jc down. Okay, sorry, it will go to if they are not equal, if a is not equal, then it will jump to the label again. Okay, then it will check whether a is less than, that is the value at a is less than the value at 0f0h. Okay, so this again, it is a label for handling the case where a and the value at 0f0h are not equal. So next is JC down. That is, if A is less than the value at this address, then it jumps to the down label. Okay. Then we have exchange. That is XCH A comma at R naught. So this will exchange the contents of A with the value at the memory location pointed by R naught. Okay, if a is less than, that is the value at the accumulator is less than that the value stored at 0f0h, then it will jump to down. Otherwise what it will do, it will exchange the contents. Okay, if a is greater than, and that is if the value at accumulator it is greater than that of the value at 0f0h, then it will exchange the contents. Then it will decrement r naught. Here it will decrement r naught to point back to the previous memory location, and then it will move at r naught comma, then it will store the value at the accumulator a back into the memory location pointed by r naught, and it will increment the r naught to the next memory location. Okay, this is the comparison and swapping. So here we are using CJNE A comma 0f0h comma, again this is used for comparing, and here we are swapping. Okay, that is we are exchanging the values. Next we have the loop control. Now we have two loops here. Okay, one is the inner loop and another is the outer loop. So to control the inner loop we have R2, and to control the outer loop we have R3. Now this down, it is a label for the program to flow to jump to if the carry was set in the JC instruction, that is jump if carry instruction. Okay, now next here we have DJNZ R2 comma up. So this will decrement R2 and jumps back to up label if R2 is not 0, and it will create a loop for the inner processing. Okay, then we have DJNZ R3 comma up 1. This will decrement R3 and it will jump back to this label, that is up 1 if R3 is not 0, and it will create the outer loop. And at last we have termination of the program, that is there is an infinite loop by using this instruction, that is h colon s jump h. Okay, so here this program enters a infinite loop at level h, and then we'll terminate the program by using the end directive. So here this is the program which we have used, and this is the input which will be giving to the program, that is at 30h location, starting from 30h location we will give 4 numbers, because here we have considered the array size as 4. You can change the array size. Okay, you can take 10, 12, 11, you can take array size of your own choice. I have taken here 4, so I have to enter 4 numbers. I have taken 4, 3, 2, 1, and I should get the output as 1, 2, 3, 4. So here the numbers are not arranged in the ascending order. After execution, that is at the output, sorry, here the output spelling is wrong. At the output you should get it as 1, 2, 3, 4. Okay, now we will see the execution of the program. We'll open the Heal software. We'll go to project, new vision project. I will use the previously used project, that is Alice, and I'll save it. Yes. I will search for the microchip device. Here it is, microchip. Click on this plus symbol and search for 8089C51. Okay, here you have 8089C51. Okay. Copy startup.a51 to project folder and add file to project. No. Now go to the file, open new file, type your program here. I will directly copy the program and I will paste it here. Now you have to save the program. So we will save the program as asc.asm. Okay, always you have to save the program with .asm instruction. Now next, click on the plus sign of this target. You will get source group 1. Right click on this source group 1 and click on add existing files to group source group 1. Search your program here. We have given the name as asc.asm. Select that, add and close. Now you have to see whether your program has been added in the source group 1. Click on this plus symbol. So your program has been added. Now go to the project. Click on build target. So you can see here there are no errors and there are 0 warnings. Go to debug, start or stop debug session, then OK. Now we have to give the input at the memory location starting from 30H. So I'll take it as I:30H. I'll give the numbers as 4, 3, 2, 1. Okay. So now the numbers are not arranged in the ascending order. You can see here. Okay. It is 4, 3, 2, 1. Now I'll run the program. Now you can see at the same memory locations starting from 30H, the numbers are being arranged in the ascending order, that is 1, 2, 3, 4. Okay. This is the program to arrange the numbers, okay, or an array of numbers in ascending order. Now we will see how to do or how to arrange the array of numbers in descending order. So here you have to make a slight change in this program, okay, of the ascending program. Here you have at the label again :JC down, just you have to make it JNC. Okay, jump if no carry. Now save this, go to project, then you have to rebuild all target files, go to debug, click on start or stop debug session. Okay. Now I'll give the numbers in ascending order. It has to rearrange that in the descending order. So 2, 3, 4. Go to debug, run. So now you can see the numbers are arranged in the descending order, that is 4, 3, 2, 1. So these are the two programs. One is for ascending and another is for descending by using the bubble sort. Hope you understand the program. Thank you.